we want to express 1 divided by 1 minus x to the second power as a power series. Remind yourself of geometric series. For a geometric series, remember that if you have the summation of x to the n and start from 0 to infinity, which is 1 plus x squared plus the rest of the terms, as long as the absolute value of x is less than 1, this guy is convergent to 1 divided by 1 minus x. So we're going to use this information. What is the similarity between 1 divided by 1 minus x and 1 divided by 1 minus x to the second power? We are looking for similarities between 1 divided by 1 minus x and 1 divided by 1 minus x squared. Similarities, or finding some kind of relation between these two. Go back to elementary calculus. What is the derivative of 1 divided by 1 minus x? The derivative of 1 divided by 1 minus x, by quotient rule, it is equal to 0 times 1 minus x minus the derivative of 1 minus x is negative 1 divided by 1 minus x to the second power. So the derivative is equal to 1 over 1 minus x squared. So if I take the derivative of the geometric series, it gives me this new function 1 over 1 minus x to the second power. So if I take the derivative of 1 divided by 1 minus x, we get 1 divided by 1 minus x to the second power. Let me put it in parentheses here. We know that the summation of x to the n and start from 0 to infinity is 1 plus x squared plus x cubed plus x to the fourth plus the rest of the terms. And as long as absolute value of x is less than 1, it is converges to 1 divided by 1 minus x. Now take the derivative of everything term by term. Of the power series. So here you have the derivative of 1, which is going to be 0, plus the derivative of x, which is going to be 1, plus the derivative of x squared, which is 2x, plus the derivative of x cubed, which is 3x squared, plus the rest of the terms. And on the right-hand side, the derivative of 1 divided by 1 minus x, we saw that it is nothing but 1 divided by 1 minus x to the second power. But what is the power series representation? You only need to take the derivative of x to the n and shift this guy a little bit, because your very first term is equal to 0. So this becomes the summation of n x to n minus 1. And now my n starts at 1, goes to infinity. Pay attention to these shifts, everybody. When you're taking the derivative of x to the n, it becomes n x to n minus 1. Your very first term is 0. You cannot plug in 0 here as n, because you get 0 times x to the power negative 1. We don't have something like that. We have 1 plus 2x plus 3x squared, and so on. So to recap, if you take the derivative of x to the n and start from 0 to infinity, this is equal to the summation of n x to power n minus 1, and now start at 1 goes to infinity. So I expect you to ask, what if I take the second derivative? Okay, if you take the second derivative of x to the n and start from 0 to infinity, you're basically taking the derivative of n x to n minus 1 and start from 1 to infinity, which is equal to the summation of n times n minus 1 x to power n minus 2 and start from 2 to infinity. You can continue this process. Just be careful about the index. The very first index was 0. When you take the first derivative, it becomes 1. When you take the second derivative, it becomes 2, and so on. So let us recap what we did. We want to express 1 divided by 1 minus x to the second power as power series. We remind ourselves of the definition of geometric series using power series. As long as the absolute value of x is less than 1, this power series converges to 1 over 1 minus x. So our goal is to find relations or similarities between 1 over 1 minus x and 1 over 1 minus x squared. We remind ourselves of elementary calculus. The derivative of 1 divided by 1 minus x is equal to 1 over 1 minus x to the second power. So if I take the derivative of 1 over 1 minus x, we get this function that we're trying to find the power series for it. Since the summation of x to the n is 1 plus x squared plus x cubed, and as long as absolute value of x is less than 1, it representing 1 divided by 1 minus x, we take the derivative of this power series term by term, and also we have to take the derivative of the function that is representing. The derivative of 1 is 0, the derivative of x is 1, the derivative of x squared is 2x, the derivative of x cubed is 3x squared, and so on. And we just saw that the derivative of 1 over 1 minus x is 1 divided by 1 minus x to the second power. Or basically, you are taking the derivative of the general term of your series. The derivative of x to the n is n x to power n minus 1. But be careful about the index. Your original index was 0. Your new index is starting at 1. You're shifting this. You are not allowed to plug in 0 back into this new power series because you get x to power negative 1. It doesn't exist. So if you take the derivative of power series, you're basically taking the derivative of the general term and you are shifting the index 1 unit. If you want to take the second derivative of the power series, you're basically taking the derivative of its derivative, which becomes now n times n minus 1 times x to power n minus 2, and the index starts at 2.